Hi, and welcome back to Data Innovation Summit 2025 Data Octagon program. Right now with us, we have Jon Su, who is a solution architect and Snowplow, and we will be doing basically a product review of the latest updates with Snowplow. So we are super happy to have you here.
Yeah, glad to be here.
Yeah, I'm super excited about what you guys have to present today. Obviously, today has been a lot of discussion about like AI and analytics and everything else, but deep down we all know that this is actually equal to data and basically how good quality data organization have. And I believe this is basically what your organization is currently doing. Can you tell us a little bit more like the background of Snowplow first of all, and what you have installed for us today?
Yeah, sure, absolutely. So for those who don't know, Snowplow is essentially a customer data infrastructure platform. And what we do really well, I guess, is create behavioral data from your digital platforms. So that could be a website, it could be an app, it could be a backend service. And we essentially are streaming and delivering that data directly into, say, a warehouse or lake. Perfect. Or real-time stream to kind of power those, operational and analytical use cases. So some of the companies that we work with tend to be quite enterprise, and they focus on the customer experience. So use cases such as like personalization or recommendation engines is right in our wheelhouse. And for those, data quality is key.
Yeah, perfect. And I believe you have something special for us today, so hopefully, maybe we can go through it. So I'm looking forward to see how everything looks under the hood.
Yeah,
so,
cool, thank you.
Please take us forward.
Cool. So essentially, as I mentioned, so Snowplow is customer data infrastructure, and its purpose is really to help you collect, manage, govern, and operationalize that AI-ready behavioral data for organizations. And the reason that we kind of go with this behavioral data first approach is because behavioral data is the best way you can kind of tell what customers are doing on a website or app, and then predict what they may do in the future, and then you can kind of use that information to give them that personalized experience,
right.
Which is really powerful for these businesses in terms of providing value for those end customers. So just in terms of how our Snowplow CDI platform kind of works, is on the left here on your website or app, we have what we call trackers, which is the SDKs that are responsible for emitting data into our Snowplow pipeline. As part of that, we then will have our schema validation. So what we follow is a schema on write approach as opposed to a schema on read approach.
Right.
And that is basically saying like before we actually send any events, you have to predefine ahead of time what that schema for that event might look like.
Just to pause you here because we had a discussion before this event. Can you tell us a little bit more why this is important to be done on this way, specific like you're doing it?
Yeah, great question. So it goes back to that, 1,000-year-old question. So with traditional analytics, what would happen is if you have any type of bad data, a business stakeholder will go to an analyst or data science, and they'll basically go to them and say, like, can you please explain to me why this data does not look correct? And then obviously analysts will be able to like justify with some reasoning of like, this is the reasons why the data is not accurate, but still kind of usable. And that kind of works in a traditional analytics world, right? With AI at the moment, everyone wants to kind of do things in real time. So essentially, as opposed to waiting for that data to land in a warehouse, have an analyst, analyze it, it's now going straight into like a real-time stream to operationalize it. And there's no way for a human to justify the reason why data is bad. So you kind of have to have that data quality and schema predefined ahead of time, which is kind of why we decided to go with this schema on write versus a schema on read approach.
Right, super great then, super great. Cool. Continue, please.
Yeah. So underneath the hood, we also have a thing called data products. So in the data world, data products is used by everyone, and they mean different things. On our Snowplow CDI platform, data products is essentially a data contract. And what it's doing is it's binding a single source of truth from the data producers upstream on the website developers all the way down to the consumer, or the data consumer. And so basically it's a single source of truth so that everyone understands what is being collected, what it means, so that that information can then be used by even machines, for example, to produce like that unified definition for the data.
Right.
So I guess one of the reasons that data leaders choose to use Snowplow, there's 3 key differentiators that we have. So the first one is we follow a shift left data quality and data governance approach, which basically means we build governance into that entire data lifecycle from the time of data creation all the way to the delivery of that data for operational or analytical use cases. And then another key differentiator with some of our competitors is we deliver AI-ready data. So the data that we deliver into those warehouses, lakes, or streams in real times, they are basically arrive there almost immediately, and they're ready to use. You don't need to kind of do that manual wrangling and clean it up and prep, which is kind of where a lot of time is wasted currently with data scientists, because they're busy cleaning that data as opposed to using the data to create value for a business.
Super interesting.
Cool. So I guess today we'll focus on data quality. So I will jump into the demo. So this is just a demo website that we have. So if I kind of refresh the page, you can kind of see on the left here, we're emitting a number of different events. So the events that we're emitting is like the page view, because a person has viewed the page. We also have a couple of different e-commerce related events. So there are things like, a person saw a product, for example, they saw a promotional banner on that site. But if you notice, there's a little red exclamation mark on one of these events. And this event is essentially tracking this element here. So a person is seeing that promotional banner. So this little icon basically means it's a bad event. And if we kind of scroll on the right here to kind of see the reason, we can kind of see this is the data that we're sending. So essentially we're sending a customer data infrastructure product category. We have a price and then a currency. So for each event and entity that we track in Snowplow, you have basically predefined a schema ahead of time.
Of course.
So that schema is essentially a JSON file where you essentially will list all the property and values that you expect to see for that event. So we'll have also metadata around like what each attribute kind of means. It will specify, for example, what type a particular field needs to be. Like, is it a string? Is it a number? Is it like an array of objects even? And more importantly, it sets rules around what that data should look like. So for example, is that like a minimum value, a maximum value? Is it a required or optional field? That's all controlled within this Git-backed schema definition for every single event and entity that we send in Snowplow. So this is a good, we'll see there's a bad one. So this is for a product schema. So now if we kind of just go into your products, we kind of look, zoom in a little. So we can kind of see the reason for the error is price is not of a type number. So it means the price field, we're not sending a number, we're sending something else. And we also require a property of ID. So now if we just kind of go back to the schema, which controls the rules and logic, that is because here we have specified. So if we go down a little, so price. So we've just defined the field, got price. We've given like a meta description of what it means so that downstream consumers know what it is. Exactly. We specify that it needs a maximum value and a minimum value of 0. And more importantly, we specify it needs to be a number field. Okay. And then similarly, we have a number of required fields. So we basically say for every time you want to send a product entity, you need the product ID, you need the category, you need the price, and you need the currency.
Perfect.
Okay, so that was kind of the errors. So now if we go back to the data, because you always go back to the source.
Of course.
So category is there, right? Price is there as well, good. But currency. But the reason for that error of price being not a number, so it's because we have this value here. So a developer has basically said, replace this placeholder value before we deploy to prod, but they obviously forgot to do that. And that is the reason. So now developers or data consumers can really easily pinpoint what is the reason for that bad data quality, right? So now if we go back into the data, replace this with a actual number. So 1, 2, 3, for example. You refresh. Let's refresh one more time. Cool. Oh, we still got an error. That's not good.
Probably just syntax.
We've forgotten ID. Yeah, that's right. Those 2 errors, not just one, right? So now if we go back to here, we give it an ID field. Can't spell. ID. And then just put a test. Put a T, just to make life easy. All right. Hopefully this gets us the way. Ooh, that's not good.
That's good.
Let's see what's the
Getting
reason.
exciting.
Just refresh this one. I got a full stop on ID.
Exactly.
Is that the reason? Because we didn't put that key correctly.
Exactly.
So now, now, okay. Hopefully, fingers crossed.
There we go.
Hey, so screen. Okay,
Bravo.
cool. So it's now all good, it's valid, it's going to land into your warehouse or lake directly or even your real-time stream, and it's going to be perfectly formatted to that schema that you've defined.
Perfect.
What's more that we have in our platform is we also have a notion of data products, which is a grouping of different events and entities for a specific use case.
Right.
So as an example, this is for an e-commerce use case. So here we essentially are defining what that use case is and kind of giving a description. We also specify from what sources of data that we can expect that event to be emitted from, because a lot of brands, for example, will have multiple websites and multiple apps, right? So this clearly defines. One very important thing, we also specify who's responsible for maintaining that data. Because it goes back to that age-old question again, right? If everyone's responsible for the data, who's responsible? Exactly. So you need one person.
True.
So you can specify like what team is responsible, if there's a primary owner as example. And then within the data product, this is where it encapsulates all those events and entities. So we're saying for this particular use case, we care about all these types of events. And for each event, if we kind of jump in, if we load, you can kind of see it's still backed by those get back to schemas. So you can kind of control all that in your GitHub or GitLab profile, and it will sync automatically with your B2P console. So as you can kind of see, we have all the values and like what it needs and what's the requirements. So it's quite clear for documentation purposes. One very key important thing also about our schemas is if you notice we have numbers here. So this is our semantic versions that we use for our schema changes. So whenever you want to add, replace, or update or remove a field, the version of that schema will actually change, so that we're quite clear in the tracking definition. You basically will specify a specific schema version to actually query, and then we have that ability to basically have multiple concurrent versions running. And when it's landed in the warehouse, you also see those concurrent versions in separate columns. So you can kind of have backwards compatibility, but also make changes and have that robustness.
Perfect. And we have, is there anything else that we'd like to show us?
Yes, so last thing is, I'm not sure if you remember those bad events that we saw earlier, those errors?
I remember them, yes.
Okay. Well, basically, we can also land them into a separate location inside the warehouse. So if an event fails that validation against the schema, they essentially will land in the warehouse.
And for which purpose? For learning purposes and etc., or to
very
avoid
good question. So the key... So the key use cases here, you got two options. The first one is to learn what's the error, go back in time and fix it at the upstream implementation. So that's usually the first thing you can do. The other cool thing you can also do is patch the data. So for example, if it's just a very unimportant attribute that kind of like messed with the whole row of the data, you can still use the other attributes that we send. So by having the failed events in the warehouse, essentially what you can see here, if I expand, so you have the failure messages. So for example, the ID was missing, but it's required. In the schema, it has the event ID, so the event row. But what's even cooler is we actually send all the other data with this table. So if we kind of go across here, you can see we have all these cool granular canonical fields that Snowplow offers out of the box for each individual event, and some of those fields might have valid data, So you may be able to reuse that and replay that data against your production. That way, still keeping it not polluting your production data, unless you do that final check.
No, this is smart thing, because the only way forward is learning from the mistakes. So super good.
And then within our console, because you got the failed events in the warehouse, we also have an API available where it basically gives you like a nice UI, so that it kind of visualizes that data for the people that don't need to work in the warehouse. And it will basically give you the same information as what you previously saw in the failed events within Snowflake. So as you can kind of see here, so these are all the errors and how many times they've occurred, the volume. And you see the same information. So it's saying what the error was, for example, the certain errors, if it's required, how do you fix it, where it's coming from, what the actual event ID was. You can even generate the SQL query if you want to run against the warehouse, so they can kind of use that as a starting base, build on top of it, patch it, move it into production. That's all available here within the B2P console.
Perfect. I saw we have a little bit of time, so I saw that you jumped one of the slides, which was actually about your customers. Can you tell us a little bit more, who is the user of this technology mostly, and in terms of job title? Is it more like the marketeers can do this, the product developers, or is it going to be the data scientist, the AI? And which typical organization is actually a user of Snowplow?
Yeah, great question. So we tend to go with a use case agnostic approach. And the reason that we say that is because behavioral data at the end of the day is about the end customer, And the ways that a brand interacts with customers these days, it could be across multiple touch points. It could be through marketing, it could be new product feature, data science models, even your supports team, and whatever. So what Snowplow really is good for is basically powering a horizontal value chain of use
Right.
cases. So regardless if you're coming from product or marketing, there's
Yes.
probably a use case of that customer data.
Right.
So at the core of everything is customer data.
Right.
So long as you have a use case that requires that customer data, Snowplow is a great fit. We work with B2B companies, B2C. So,
Yes.
for example, we work with Burberry, Strava,
Yeah, Lego's there, I can
Lego
see it,
as well,
right.
Samsung, and as you can see, like all these brands, they have like different types of customer profiles, right?
Right.
But the use cases may vary quite differently.
Yes.
So there might be personalization, recommendation engines, fraud detections for financial
Yes.
services.
Would you classify them a little bit more like organizations that require and work with the real-time data, where they require speed but also quality of the data? Or, mostly?
Yes. So we do have two different paradigms that we can allow. So the first one is that very traditional one where you load data in the warehouse, you build models, analytical reports, you export it somewhere else and use that data. We then also have this second use case where with a real-time stream, we can actually stream it immediately to wherever you need that data, so you can in real time action on that behavioral data, do the next best action,
Yes.
meet the customer where they are at their customer journey at that point in time.
Yes, perfect, super good. So thank you so much for this, and thank you for the beautiful
Thanks for
demo.
having me.
Yeah,
Thanks for
looking
having
forward
me.
to it. Thank you
Yeah,
so much.
sure.
Thank you.